I want to start my talk with a question. I want you to think about what is common between the following scenarios that I'm going to show you. So the first scenario is a collapsed building where people might be trapped behind piles of debris. The second scenario is a building where one of its apartments caught on fire. And the last scenario is a complex surgery inside of the human heart. So the first thing that is common between these three scenarios is that we need to reach to a specific location in space. And the second thing that is common between them is that once we reach to this specific location, we need to transfer materials. So in the first scenario, we need to transfer air for the survivors. In the second scenario, we need to transfer water in order to put out the fire. And in the last case, we need to transfer some medicine or some medical tools. So basically, we want to create a device that can cope with these scenarios, with these challenges. So we are looking for a magic tube. We are looking for a magic tube that can stretch and remain stable. We look for a magic tube that is going to have a simple actuation because we don't want anything that is going to be too complex to operate. We want fast movement in space because in many cases it's very crucial to reach to this final location as fast as possible. We need to overcome gravity in order to reach to the fourth floor and put out the fire. And lastly, we need to be able to perform complex maneuvers if we want to reach to specific locations. So I want to introduce you to this magic tube. This is just a daily life structure that we all know in many aspects of life. It can be a kid's toys. It can be a drinking straw that you have the part that bend. And actually, the first thing that I show you is from the back of my dryer. So that's great. We have a structure that can stretch and remain stable, right? I stretch it and it's stable. But we are still yet to overcome the last requirements. So I want to deal with the next requirement, the simple actuation. So how can we exactly activate it? I mean, I can't open it and reach with my hand to the fourth floor because apparently I'm not tall enough. So we need some inner actuation. So how can we activate it? So imagine that we take the structure and we're going to seal one edge of the structure and we're going to connect the pump to the other side. And then we're just going to inflate it, just like a balloon. So it's going to be open. And I want to show you a short demonstration of it. Great. So just by connecting a pump and sealing the other edge, we have simple actuation. It was very easy to actuate it. And in addition, it's fast movement in space, right? It only takes a couple of seconds to be fully open. But we are yet to overcome the last two and the most challenges requirements. We need to be able to overcome gravity, and we need to be able to perform complex maneuvers. So we need an additional mechanism. So the first mechanism that we need is we need to understand how can we make it turn. And the solution to this question is basically constraints. Imagine that I'm going to take one side of this structure and I'm going to glue it. I'm going to force them to stick together so they will not be able to stretch. And then when I'm going to inflate the structure, this side cannot be stretched, the other side can be stretched, so I can get the turning. And because I like to show you demonstration of things that I'm talking about, I want to show you a short example. What you see here is a top view of this magic tube that connected to a pump and the other side is sealed. And I put constraint on the right spot so it can start from point A, its initial configuration, and reach to point B with this black line. So let's see how it works. Great, we start at point A, we reach to point B. But did you notice that the opening was quite chaotic? Let's watch it again. So if I will stop one frame from this video, you can see that all the structure go to the left and then return to the right. And let's imagine that we had a wall and we had a door that we want to go to. So you can see that in this case, we are going to be stuck on the wall and we will not be able to reach to point B. So we need an additional mechanism. We need a mechanism that will help us to follow the path, because that's the only way that we can perform complex maneuvers. So how the structure can follow the path? the solution to this is viscous actuation. And when I say viscous actuation, I mean we are going to use viscous liquid, just like honey that we all have in our kitchens, instead of air. So in a recent paper that we published, we discovered that if we inflate the structure with viscous liquid instead of using air, we get a well-ordered opening of the structure. So once again, I like to show a demonstration. So the left video is the video that I just showed you with the chaotic opening. And now you can see the difference with using viscous actuation. That's great. We accomplished all the requirements that we set. So unfortunately, I can pick a random building and set up a fire on one of its apartments because it's illegal. But what I can do is I can conduct an experiment at the lab. So another demonstration. So I build a house-like structure with 2 floors. And we have at point A our magic tube, and we have a fire at point B on the 2nd floor. And we have a specific path in space where we can reach from point A to point B. We can see in this example that we have a complex term. We can see that we need to overcome gravity. And we see that we have narrow space that is forced us to follow the path. Otherwise, we will not be able to reach to the fire, right? So let's see how it works. By the way, the video is in real time. Yay, we did it. But can we cope with the real life scenarios that I show you? So the general solution is not yet, because we might be able to purchase this magic tube at many sizes, at many lengths. The fabrication method of this structure is the same fabrication method since 1962. For over 60 years, the same fabrication method. This fabrication method, actually, what you see is what you get. You buy this magic tube, and you can't know what you purchase. So basically, you have lack of control over the mechanical properties, which is a very crucial component to us, right? In the case of putting out fire, we need the structure to be very stiff so it can hold the high pressure of the water. And in the case of performing complex maneuver inside the earth, we want the structure to be less stiff because we don't want to harm the human body. And in addition, there is differences between the same identical tube. I want to show you. I purchased 2 same identical blue color, the same size, and you can see that there is a big difference between the lengths of 2 of them. So my next challenge is to find a new fabrication method where we can control the mechanical properties of the structure, and we can predict and get the mechanical properties that we want in order to be able to cope with this scenario. So we had complex scenarios, different scenarios, and by fabricating and controlling the maneuvers of the tube, we can deal with these scenarios outside the laboratory in the real life. Thank you.